Welcome back, and this is part 2 of my rectangular approximation method for areas and volumes. And in this video I'll do an example for approximating a volume as promised in my first video. And so let's just take a curve. Here's the example: y is equal to sine x curve, and you're gonna revolve this about the x-axis, but it's only going to be on the interval from 0 to pi. So you're gonna rotate this along the x-axis, and I want to find the estimate of the volume of this ellipsoid shape that you get at the end. So let's just sketch out sine x from 0 to pi, and so we can find out, what we're talking about. This is pi over 2, right? And so you want to rotate this along the x-axis, and you want to estimate, what you get. So basically, you're gonna get some kind of, ellipsoid. It's kind of like a sphere, but not really. And you're gonna split this up into certain subintervals, like that. And these subintervals are gonna be comprised of cylinders, actually. And it's going to be, something like, it's, hard to draw, but they're going to be, if you can imagine this being rotated, and you have, like, slices going like this, and they're going to be three-dimensional slices of a curved thing, so you're really getting cylinders with radiuses of this height, which here, actually, pi over 2, this is 1, so of this kind of radius that goes along, all these places. So let's set some guidelines for how we're going to do this. So let's say I want to split it up into, we're gonna use the left-hand approximation method, and we're gonna split it up into four subintervals. So this is how we're gonna do it. So now we have here the 4 subintervals: 0, pi over 4, pi over 2, 3 pi over 4, and pi, as shown there. And we're gonna rotate this again. Just explaining again, you're going to rotate this, and you're going to have these cylinders, neat slices going across like that. So the volume of a cylinder, the formula for the volume of a cylinder is pi r squared h. And here we're gonna say that this here is the height. So these cylinders, I can draw one like this. The radius, let's see if you can see this, the radius is going to be like that. So this is the radius, and that's going to be the height there. And the height is going to be like this. And it's going to be the second part of the cylinder. And this is going to be the height is actually going to be this part here. So the radius is going to be this, and the height will be this. So the radius and the height, just like that. Of that cylinder. So we're gonna have four of these times 4. So we're gonna have 4 of these cylinders going across. All right. So that's the conceptual bit behind it. Now let's actually go down and get into this math here. So if we have the volume of each cylinder is pi r squared h, all we have to do now is just write out the 4 volumes of these cylinders and just add them together. So that's not too hard. So each cylinder will have the height as the same thing. So the volume, we're going to add all these volumes together, but we can take out the pi, because that's going to be common, and the height, which is pi over 4, because that's our common height, and that's the distance between our intervals. And then we can have the r squared along the inside. So that this, again, we're doing the LRAM, or the left-hand rectangular approximation method. And as we do this, we're gonna have sine of 0, because that's this part, right? Because as we're using this, we want to use the LRAM, so we're gonna just do that, and that. And these are actually gonna be, these are actually cylinders rotated around, but this is the heights, or rather in this case the radiuses that we're using, plus the sine of pi over 2 squared plus sine of 3 pi over 4 squared, and, plus sine of, this should be, it was pi over 4 here, squared, sine of pi over 2 squared plus sine of 3 pi over 4 squared. And sine of 0 squared is 0. Sine of pi over 4 squared is 0.5. It's just a half, and this is 1. It's another half there. And you still have pi over 4 and pi on the outside, because this is the height and that's the regular pi in the formula. And if you continue this out, you just get that times, this is 2 times pi squared over 4, and if you were to put this in a decimal form, it's approximately 4.9348. So according to the rectangular approximation method, the volume, according to the LRAM, is 4.9348 if the first from 0 to pi is rotated around the x-axis.